Hello everyone, this is Charu Sharma this side, and I hope you have all seen my first video of gravitation which I kept on the channel, which I posted on the channel, Gravitation Part 1 lesson, where I taught you about the Kepler laws and Newton's law of gravitation. Kepler laws and Newton's law of gravitation. So the basics were all taught there, the basic concepts which you need to know, and what was the theory there you need to know. Then I also gave you a small homework that read up your NCERT and also solve some numericals. But I still know some people are lazy to open up their NCERT and read up the points. So I thought, why not myself to bring some extra theory points which you can see in your questions, in your objective questions, and some important typical questions which can give you a base of solving other numericals as well. So in this video we will be discussing some important theory points. I don't say that after watching this video you don't need to read up your NCERT. It's of course very necessary, but at least you can get some important theory points as a revision in this video. So let's get started. So the first point is about the relative strength. So what is the relative strength? It means that you have different types of forces, right? You have nuclear forces, you have electromagnetic forces, and you have gravitational forces. So now if you start arranging them on the basis of this strength, like how much strong one force is, then you will observe that the strong nuclear force is the strongest force. Then comes your electromagnetic force, then comes your weak nuclear force, and then comes your gravitational force. Okay, and what are nuclear forces? They exist in the atom. Between the nucleus of an atom, the nuclear forces exist. Now if I come to about ranges, what do you mean by range? It means like that force is valid up to what distance you can observe that force. That is called as ranges. Gravitational, so if you see them in a order, gravitational force will have more range as compared to electromagnetic force and as compared to nuclear forces. Okay, so these were some important questions, like you can see them in your points or match the following, some type of objective questions. There you can see these points. Next, coming to the third point, if you observe in oceans, especially in the night time, the tides are very high. The water tides are very high in the oceans. That is because, what is the reason behind those tides is your gravitational force of attraction between the moon and the earth. So this was your third point. Let's come to the fourth point. So I already taught in the law of in the Kepler law that what is distance of closest approach and what is the distance of greatest approach. So if you don't know, please go and watch out those lessons which are already posted on the channel. So distance of closest approach and distance of greatest approach. So if this was your eclipse, here was your sun, and so this, if your planet is at this position, then this is the maximum distance between the sun and the planet. This maximum distance was called as apogee, and the position was called as apohelion. And similarly, if this planet was at this position, so this is the minimum distance between the planet and the sun, so this was called as perigee, and the position was called as perihelion. Okay, so you should know what is perigee, what is apogee. They may give you in pick out the wrong statements, like those type of questions may. Okay, now moving further. So in the second law of Kepler, the second law of areas of which was the second law of Kepler, in that I told you that equal amount of area covered in equal amount of time is equals to constant, and that constant value was L upon 2m. So I thought of, why not let's derive this thing, because once you know how to derive something, you start feeling physics interesting. Instead of boredom, you start feeling it as interesting because you come to know how to derive equations. So here L by 2m, how do you get this constant value? Just you need to consider the area of the triangle. Suppose the planet from here to here it moves, from this position to this position it moves in that eclipse, and with the velocity v it moves. So if you mark up this area will become to be a figure of triangle, no, from this position to this position, and you joined with the sun, this appears to be like a triangle. So you just need to, as per the statement here, area is there, so we need to calculate this area. So if you calculate this area, how do you calculate area? That is half into base into height. So what is height over here? Height is this distance, right? This distance can be considered as the radius or r. And what is the base? This base you can consider as arc, the arc value itself. This base you can consider as arc. And how do you calculate arc? Radius into angular displacement. Angular displacement is nothing but, suppose this was your triangle, so this angle, this theta angle is nothing but your angular displacement. By angle, how much it has displaced. So arc value is calculated r d theta. So then you put that in the equation, half into b into h. So if you put half into b into h, half into radius into r d theta, and now you get this equation. This equation you need to differentiate with time. So if you differentiate that equation, dA by dt is equals to half into r d theta upon dt. So this part is constant, so it comes out half into r square, and d theta by dt goes inside. So d theta by dt, that is displacement by time. It's nothing but angular displacement by time is nothing but angular velocity. This is angular velocity. So angular velocity you get. So dA by d theta is equals to half into r square omega. Now if you know that V is equals to r omega, V is equals to r omega. If there is any disturbance backside, please ignore that. V is equals to r omega. So V is equals to r omega. If you take here 1 r, if you take common outside, and you put here in this equation and rearrange, you get it as half into r into V. Now what is V is equals to r omega is nothing but your velocity is equals to radius into angular velocity. I hope you know this equation. Now you need to multiply and divide by m and m. So you will get above mvr. Now I said you in the lecture itself that angular momentum is nothing but mvr, that is mass into velocity into radius. So your dA by dA by dt is equals to L upon 2m. So like that you derive this derivation for law of areas. How to derive that constant L by 2m, how to derive this. But in exam, if you sit deriving, it's waste of time. Instead that you can just remember that how you are supposed to derive it. Okay, now let's move further. Okay, so the next point is why we learn eccentricity. So in the lecture I told you E is equals to under root of 1 minus b square upon a square, right? About eccentricity. I told you this equation. B is the semi-minor axis and A is semi-major axis. But why is it necessary to learn this equation upon? Because you come to know from this equation about the shape of the orbits. So whatever the E value you get, with that you can differ what is the shape of the orbit, in which orbit the planet or planetary body is revolving. You can get to know from this E is equals to this equation. Okay, E is equals to under root 1 minus b square upon a square. So no need to remember, just for an idea I am telling you this. So if you get E is equals to greater than 1, and if your total energy value is positive, then the path is hyperbolic. If you get E is equals to less than 1, this is what is in our syllabus, that if E is equals to less than 1 and your total energy value is negative. That's why when you will move further, gravitation chapter, when we will do part 2 and we will know how to calculate energies, gravitational potential energy, kinetic energy, total energy, that time we will take total energy and negative. That's why, because E value was less than 1, that's why total energy is taken as negative, and hence we convert that the path is elliptical. Now if E is equals to 0, If E was positive, the path was hyperbolic. If E is negative, the path is elliptical. But if E is 0, then there are two possible cases. It depends upon your energy value. If the energy value was negative, then if E is equals to 0, then the path is circular. And if your total energy is also 0 and E is also 0, then your path is said to be parabolic. Okay. Now the 8th point, this is already explained in the lesson. Just you need to remember this formula. This is very important. Suppose if it is given that generally what we say that force is inversely proportional to r square. Instead of putting r square, if they give you just forces inversely proportional to r to the power n, then what is time proportional to? In this case, the time was proportional to r to the power 3 by 2, right? T square is directly proportional to r to the power 3. This was the equation. Suppose if this is n, we don't know which value it is, then that time is directly proportional to r to the power n plus 1 by 2. You need to remember this. This is very important. And in lesson, in the first video, I already told you how to derive also. But sometimes deriving is not possible and you need to do 1 minute a question. So derivation is not possible. So here you need to remember this formula, and it's very important. Direct question. If you know the formula, you can just solve the question in seconds. Okay. So let's move on to the 9th point. What does that say? Sometimes graphical questions play an important role, because graphical questions are like you know the answer or you don't know the answer, and once you know the concept, you can get to the answer in just a minute. And it's very easy to score up the marks also. So if F is equals to G into M upon R square. Now this thing, if they ask you in a graphical form, what can be the possibilities? They will ask you what is the graph relation between F and R square. Between F and R, or what is the relation between force and the distance. If you want to put it in a graph according to Newton's law of gravitation, then what it is, you know that for the equations like F is inversely proportional to R, like for the equations like something A is inversely proportional to B, or some A is inversely proportional to B square. For these two cases, your graph is always a hyperbola. Always a hyperbola, like this inversely proportional things. For these two possibilities, your graph is hyperbola. So here also it is like that possibility, no? F is inversely proportional to R square. It's like second case. So that's why your graph is a hyperbola. And always gravitational force is always attractive. Okay, remember this. And one more thing, gravitational force is always independent of the medium. It will never depend upon the medium. Okay, for example, if I am taking a beaker full of water, assume this is water, and a beaker full of glycerin, okay, and I put two bodies, body A and body B, separated at the distance r in water, okay, they experience a gravitational force F. Now similarly, the same two bodies I am putting in glycerin, this is glycerin, and same distance, I am keeping mass same, body same, distance same, everything is same. Now if you see the equation of gravitational force of attraction, what does that say? F is equals to G into M into R square. Now according to this equation, if mass is same, G is a constant, R square, and someone asks you what is the gravitational force in glycerin medium. So masses are same, distance is same, so gravitational force won't change. It will be same only. It will not depend upon the medium. Okay, so you need to remember that whatever medium it is, gravitational force won't change if the masses is same, if the bodies are same, if the distance between them is same. Only if masses was reduced, or mass was changed, or distance between them was changed, then only your gravitational force will change, because it will all depend upon the formula. Formula says F is equals to G into M upon R square. This is constant. So masses on, if these two change only, force will change. But if these two are not changing, medium is changing, force won't change. It is independent of medium. Okay, I hope you understand that very well. Now coming to gravitational shielding, it is possible or not. Okay. So gravitational shielding, remember, it is never possible. Gravitational shielding, it is never possible. See, what does it mean by shielding? It means like something to protect, to protect something. To protect something. So if I take this shell and assume its all mass is concentrated in the center. Its all mass is concentrated in the center. Now if I put another mass small m outside the shell. If I put another mass outside the shell. So gravitational shielding is not possible. Okay, what does shielding means? It means to protect something, right? To protect something. So if you consider this is your shell. Okay, so if this is your shell means inside it is hollow. Okay, so the whole mass of the shell is capital M. Now if you take another small mass m over here, so what you will observe, that the force, gravitational force of attraction on this mass m is there, and it is like as if the whole mass, capital mass of this shell is concentrated in the center as a point mass. It will be like that only. Okay, that what's case 1 say. It will be like F is equals to G into M upon R square. It will be like normally how do we find force between 2 point masses. It will be like that only. But suddenly what I do, instead of putting that small m mass outside, what I will do, I will keep that small m mass inside the shell. I will bring it inside the shell. What you will observe, now the force of attraction between this small m and capital M will not be there. Not be there. There will be F net force 0 on this small mass. Okay. So when that mass was kept inside, it won't experience any force. Okay, it won't experience any force. Why? Because that capital mass m is now distributed all over the surface now. So suppose this part is applying attractive force this side, similarly this part is applying attractive force this side. So like this, opposite forces will get cancelled, and a net force on small mass m, which is this force, which is this mass inside, it won't experience any force. Okay, I hope you got that. So if you place a mass inside the shell, it won't experience any force. So now if you see, the shell was like this, mass was kept outside and mass was kept inside. We tested both the places. So when we are keeping outside, we can see that mass was experiencing force. There was force, gravitational force of attraction between the shell and the mass. And similarly, when the mass was kept inside, there is no force. There is no force between the shell and the mass. So if you want to plot that in a way of graph, how will you plot that? So this is your force and this is the distance. So this is outside distance, right? And I am considering shell to have radius r. So this point, this distance I am considering as to be r. Okay, this much from this point up to this point, this is our distance. So in this region there is no force, so you don't need to draw any graph in this area. Only the graph will come in outside area, and that will be like a hyperbola only. This is hyperbola only, F is inversely proportional to r square. So in this area only graph will come. Graph will be plotted. Okay, graph will be plotted. Okay, now let's move on to some questions. So whatever the important theory points I already told you, what I thought of sharing with you all. So the shell theorem is important, that gravitational shielding is not possible, and if you keep small mass m outside, it won't experience any gravitational force, but if you keep small mass if you keep small mass outside, it will experience gravitational force of attraction, but if you keep small mass m inside, it won't experience any gravitational force of attraction. So F net inside will be 0. F net inside will be 0. Okay. So now let's move on to some important questions, typical questions. So this is the first question. Two objects of masses 4 kg and 3 kg are placed on along x and y axis away from origin. 1 kg kept on the origin and distance is 1 meter. Okay, find F net on the origin. So see, first of all, in physics you start proceeding with the diagram. Draw the possible diagram for the question. So they are saying that 4 kg is kept on x axis and 3 kg is kept on y axis at the distance of 1 meter and 1 meter. So this was 4 kg and this is 3 kg. Oh, why is it coming like that? 3 kg. Okay, and you have 1 kg mass kept at the origin. You have 1 kg mass kept at the origin. So you will see that this 1 kg mass kept at the origin is experiencing a gravitational force of attraction this side as well as it is experiencing on this side. And now this is a force F1 and this is force F2. Now force are vectors, so we cannot directly add them, we need to vectorially do addition. So one vector is like this and another vector is like this, and angle between them is 90 degrees. So what formula you apply? F net is equals to under root of F1 square plus F2 square plus 2F1 F2 cos theta. Now what is theta? 90. Cos 90 is 0. So this whole term will get 0. It will get cancelled. So under root of F1 square plus F2 square. Now what are the values for F1? So how do you find a force? Gravitational force. F is equals to G m upon r square. G m upon r square you will find. So what is G? G is a constant, m are masses and r is the distance. So for F1 substitute that. F1 will be equal to G constant. One mass is 1 kg, another mass is 4 kg. So 1 multiply 4, and what is the distance? 1 square. So F1 value is 4G. And similarly, how do you find F2? That is equals to G into 1 into 3 upon 1 square. So that is equals to 3G. So if you solve that, you will get 4G whole square plus 3G whole square. That comes to be 16G square plus 9G square is equals to 25G square. Under root of 25G square is equals to under root of 25G square is equals to 5G. So F net value will be in this direction. F net will be in this direction, and that will be equal to 5G. So I did some very roughly, but you need to follow and you need to grab your pen and paper and do along with me. Now next question. 3 particles of mass m kept on corner of equilibrium equilateral triangle. Find F net on a particle. So this is a principle of superposition question. So like these questions are called principle of superposition. Okay, like these questions to be solved with help of principle of superposition. So you need to consider one equilateral triangle, and what is the angle? 60 degrees, no? Equilateral triangle, that's why. So here is your mass m, here is your mass m, and here is your mass m, and let us consider distances a. So any one of the particle they are asking you to find F net. So if you see, this particle, let me consider this particle will experience one force this side, F, called F, and same force it will appear this side, because the sides are of equal and distance is also equal and masses are also equal. So this particle is experiencing one force this side, another force this side, and angle between these two forces acting is 60 degrees. Again apply the same formula, under root of F1 square plus F2 square plus 2F1 F2 cos theta. Theta is cos 60. So if you solve that, under root of F square plus F square plus 2F square cos 60 is half. Cos 60 you can take it as half into half. So that comes to be under root 3F. Now why, you may ask me, why I consider both the forces equal? You see na, this one F is equals to G into M upon distance square, so A square. Similarly this force F is equals to G into M upon A square, so both are equal only, that's why I consider as F only. Okay, so I am doing sums very roughly, no matter, you need to get your pen and paper so that you will get some interest. Two particles of equal masses move in a circle of radius r under the action of their mutual attraction of gravitation. Find the speed of the each. Okay, so what they are saying, these are two particles. Let us consider particle A and this to be particle. This is A particle and this is B particle. They are moving in a circle. So they are moving in a circle. Okay, so mutual attraction of force. So they are moving in a circle, means when they are moving in a circular path, there must be a centripetal force, and whatever is the centripetal force only is reason for the mutual, for whatever the centripetal force you get, centripetal force, this will come through which, because I said you centripetal force is not a new force, it is resultant of some force. Okay, like tension is one type of force, gravitational force is one type of force, but centripetal force will be because of some other force. So here what is the reason for centripetal force is your gravitational force only. Okay, is your gravitational force only. Is your gravitational force only. So for centripetal force, how do we write mv square upon r? So let me consider mass m and what is the radius of the circle r. So mv square, the speed is given v, let me consider v square upon r, is equals to, what is the distance between these particles? This is r and this is another r. Okay, this is r distance and the another side will be r distance. So net distance between the two particles will be how much? Net distance between the two particles will be 2r, right? So this is r. So net distance will be 2r between the particles. So how do you write gravitational force? G into mass into 2r whole square. Okay, so when you solve that, will get cancelled and 1r with a 1r it will get cancelled. So v square is equals to gm upon 4r. So velocity you will get as under root of gm upon 4r, under root 4r. So velocity of each particle will be this. So what was the concept here? Just you need to equate gravitational force with centripetal force. That's it. Next, how to calculate null point. This is one concept. What is null point? You know, suppose this is your body A and this is your body B. Mass is m1, let us consider. Mass is m2, let us consider. And distance between them is d. So here both the forces will have some gravitational force of attraction between them, right? So in this d distance, there will be one point where I will keep a small mass m, and this small mass m, now suppose this mass m1 and this is mass m. So between them there is some gravitational force, and between these two there is some gravitational force. Similarly, between small m and m2 there is some gravitational force, and between m1 and m2 there is some gravitational force. But the small m, whatever the mass I keep between or outside them, this small mass m, one point will be such where whatever the gravitational force is attracted over here, the same gravitational force will be experienced on this side, and both will get nullified, so that the small m will experience F net to be 0. That point where the F net on this small particle m is 0, you call it as null point. Null point means no, F net is 0, no force over there. F net is 0, null point. So for example, if I am taking this example itself, how do you calculate null point? What you just need to write, you need to consider that small m, and you need to equate both the forces. You need to equate both the forces. Okay, let me do it once again. You need to just equate both the forces. Okay, suppose this is your m1 and this is your m2, and they are at a distance d. Okay, now suppose your null point on small m mass m is here. So I am considering that this mass was x distance far from m1 and d minus x distance far from m2. So just equate both the gravitational force. This will experience one F1 force this side and F2 force this side. Na? Just equate. F1 is equals to F2. So how you will equate that for F1? G into first mass is m1, second mass is m, upon distance between them x square is equals to G into first mass is m2, second mass is m, and distance between them is d minus x whole square. Now what you need to find, if they ask you in the question what is the null point from mass m1, then you need to tell the distance x value. If they ask you what is the null point value from mass m2, then you need to tell the value of d minus x square. That's it. You need to just solve it further. So I don't recommend you to solve it and remember. Whenever the question is asked, you just need to solve it like this. You need to equate f1 is equals to f2 for null point and find x value. That's it. Okay, is that clear? Or if you want to solve that, see, m will get cancelled, g will get cancelled, so you will get x by d minus x is equals to m1 by m2 under root. Okay, so how do you solve this? So if you put on the under roots, what you will get? Under root m1 upon x is equals to under root m2 upon d minus x, right? So under root m1 d, array, this pen is not working, under root m1 d minus under root m1 x is equals to under root m2 x. Okay, so if I take this that side, you will get under root m1 d is equals to x common under root m2 plus under root m1. So what will be the formula coming? X is equals to d into under root m1 upon under root m1 plus m2. So here though we have the m1 and m2. In exam, if they giving you 9m and m, for example, which value to be considered as m and which m1 and which values to be considered as m2, it will be a bit of confusion. So that time you can just equalize f1 is equals to f2. You can just equalize like that, or what you can do is instead you can consider the smaller mass as m1 and the bigger mass as m2. Then you can also proceed with the questions. Now there is something called binary star system on which some questions will be asked. So nothing know about that. There is one simple concept that in a binary star system what will happen, two stars will be there, no? They will revolve in between mutual attraction of force. They will revolve in a circular path, and that revolution, whatever they are revolving, whatever the rotation they are doing in that circular path, that will be just because of their mutual attraction of gravitation. And that mutual attraction of gravitation will be equal to centripetal force. So how did we do the previous sum? No, one sum we did right now, right? Like that only. So binary star system says that whatever the mutual attraction of forces between the stars are, they revolve. That mutual attraction of gravitation is responsible for their centripetal force. Now what is saying, in a double star system or nothing but binary star system, two stars of masses m1 and m2 separated by a distance d rotates about the center of mass. This is also a concept that in a double star system or in a binary star system, the central point will be their center of mass. And I hope in system of particles chapter you have learned how to get to know about center of mass. Then the common angular velocity and time period, what it will be. Okay, so you need to find. So what we will do, we will consider a star of mass m over here and same star of mass m over here. Suppose the center point is the center of mass over here and the distance between them is d. So same, how do you write gravitational force? G into mass upon d square, the distance square. And what will be their centripetal force? Mv square upon r. But here they are asking angular velocity. So instead of taking centripetal force in terms of mv square upon r, I will take as mr omega square. Mr omega square. So when you solve this, now what will be r? Tell me, it should be d by 2, na? Because r is the radius. So if this is a circle, it will be d by 2. So here you need to take radius as d by 2. D by 2. Okay. So when you solve that, how you will get? Gets cancelled. So you will get omega square is equals to 2gm upon d cube and 2gm upon d cube. So 1 second, we have forgot one important point. That's what I was thinking. Why does it comes as d cube? Okay, one important point we forgot. What did we forget? I will tell. See, this was your star system, right? This was your star system. These were your two stars, and the distance between them was d. But they are revolving around the center of mass. This is mass m1 and this is mass m2, and they are revolving around the center of mass. We don't know now center of mass is at what distance from m1 and what distance from m2. So let us consider center of mass is at a distance r1 from m1 and at a distance r2 from m2. Okay, so we will do we will just equate how we like you need to just equate centripetal force with gravitational force of attraction. So for the first mass, it will be g into m1 into m2 upon distance between them is d square is equal to first mass, center of, now centripetal force is m r omega square. So mass of the first body and r1. Now R1 in the terms of center of mass, how you will write? R1 in the terms of center of mass, how you will write? R1 is equals to distance between them multiplied by the second mass and divided by sum of them. I hope in center of mass lesson you have learned how to do this. So I will take this as m1 into r1 into omega square. Okay. Similarly for the second body we will do. Or else you can just equate this. Or in place of r1 you need to put this d into m2 by this. So g into m1 into m2 upon d square is equals to m1 into d m2 upon m1 plus m2 into omega square. See, what did I do? I just equated gravitational force of attraction is equals to centripetal force. Now centripetal force is mr omega square. So for whatever body you are doing, to that body mass you should take and that body's distance from the center of mass you should take. So I was considering m1 body. So I took the mass of m1 body and distance of m1 body from the center of mass I took as r1. So I took as r1. And how do you write r1 in terms of center of mass distance? That is equals to d into m2 divided by sum of them and into the angular velocity. If you solve this you will get, and from that only you can find time period. How is time period? Time period is equals to 2 pi by omega. That's it. You just need to solve this. So if you solve this equation, I don't have an extra slide. Okay, I will do here. If you solve this equation further, what you will get? Omega is equals to, omega square is equals to g into this m1 m2 will go that side and m1 will get cancelled. See, this m1 will get cancelled and this m2 will get cancelled. So m1 plus m2 will come up this side and this d will get multiplied with this one to get d cube. So you will get g into m1 plus m2 upon d cube. So this will be your angular velocity under root of this now. So you can remove this square over here and you can put this thing in under root. So this is your angular velocity. Time period will be t is equals to 2 pi by omega. So in place of omega just put this value. Okay, so it was a typical sum. Just the concept was you need to know what is the center of mass distance and what is the mutual attraction of gravitation and centripetal force. Okay. Now, yes, this is an important sum. See, imagine a light planet revolving around its star in a circular orbit of radius r with time period t. If then here force of attraction between the planet and the star is proportional to r to the power minus 5 by 2, then what is t proportional to r? So I said direct formula. So if they give you f is inversely proportional to r to the power n, then what is t proportional to? Direct formula, r to the power n plus 1 by 2. Now what is n value over here? 5 by 2, right? N value is 5 by 2. Just substitute 5 by 2 plus 1 divided by 2. So that comes 7 by 2, 7 by 4. So t is directly proportional to r to the power 7 by 4. Now, I give you this question as a homework. This is nothing but like principle of superposition only. You need to consider square of side A and all the four side masses are placed, equal masses. I will give you everything. You just need to solve. So this distance I am giving you as, so this whole distance is how much? Root 2a. Diagonal of a square is root 2a. Okay, this whole root 2a. Now what you need to do? Here what they are saying, find angular velocity. So what they are doing is, these four particles were in a form of square and now all these particles are moving in this circle. So this is the radius value, right? So radius, the radius will be root 2a divided by 2, half of the diagonal. Okay. So this is your homework. I will just tell the method. What you need to do, first you need to find F net on one particle. On one particle, net gravitational force on one particle. How you will find? Suppose this is particle 1, particle 2, particle 3, particle 4. So this particle is attracted this side, this side, this side. Just take this formula. F is equals to G into M into M into M upon D square. Distance between them. So here the distance is this distance, here the distance is this distance, and here this distance. So you just need to find all the three forces, F1, F2 and F3, and add them vectorially. After adding vectorially, you need to equate that net force to centripetal force like mr omega square, and this r will be this radius, and find the angular velocity. So it's combination of two sums. Two sums means like one of this type of sum, this how I found omega over here, and one of this type of sum, like of triangle, how I used to find net force on each particle. Okay, so it is a combination of these two sum. Okay, now next is this is an important typical sum. So an infinite number of particles are placed, each of mass m are placed on the positive x-axis at 1 meter, 2 meter, 4 meter, 8 meters from the origin. The magnitude of the resultant gravitational force on mass m kept at the origin is. So first draw the diagram. You need to consider x-axis and y-axis. Now they are saying that particles are placed on x-axis, positive x-axis, at distance 1 meter, 2 meter, 4 meter. So if you see 1 meter, 2 meter, 4 meter, 8 meter, these all are geometric progressions, right? Like every time the number is getting multiplied by 2. Every time, see 1 2s are again 2 times. Every time the number is getting doubled. So it doubled when the common ratio, you can find a common ratio, that time you say it to be a geometric progression. Now they are asking you to find a resultant force on a small mass m kept on the origin. So first of all, resultant force. So all the forces are in a same line. You can just vector, no need of adding vectorially, just you can add up, because all are in same line, all are having same angle. So like this only, all forces are directed. Suppose this is your particle on the origin, and all the forces are attracting in same direction only, no? All particles are attracting like the same direction. So you can just add up. Okay. So if you see F net due to the first particle, this is also mass m, but the distance is 1 meter, right? Again it comes 2 meters. So the for first particle it will be g into mass. So m into m square upon distance is 1 meter, so 1 square, plus g into, again mass is m only, so m square upon, now what is the distance? 2 meters. So square of 2 is 4, plus gm square by 4 meters. 4 into 4, 16. So like that it keeps on going. So what you will do now? You just need to add this. So for adding geometric progressions, take gm square out common, 1 by 1 plus 1 by 4 plus 1 by 16 and so on. So if it is like this, to solve this so on sum, you just need to use this formula. The net sum will be a upon 1 minus r. So what is a? The first number. Here the first number is 1 by 1. That is 1. 1 minus r is common ratio. What is the common ratio? 1 by 1 by plus 1 by 4. Common ratio will be 1 by 4 itself. 1 by 4. So 1 by 1 minus 4. That is equals to 1 by 3 by 4. So Sn comes to be, net sum comes to be 4 by 3. So 4 by 3 gm square comes here, gm square. So your net force on the origin particle is 4 by 3 gm square. So I hope you got how to solve geometric progression. This is very important. This formula is important. Sn is equals to A upon 1 minus R. A is the first number and R is the common ratio. Common ratio means second number divided by the first number. 1 by 4 divided by 1 by 1. That comes to be 1 by 4 only. When you solve, you will get F net value. Okay. So whatever sums we did, probably you are listening it first time or doing it first time, you may feel little bit hard to understand. But you need to sit by yourself, try to do these problems, and some more questions I will give you. Those also you need to practice and then practice your module. I am damn sure you will get it. And just give a reading of NCERT. You do not need to sit seriously for NCERT. Whenever after your dinner time, while sleeping, just as a novel, you can read your NCERT. That is also very helpful. You will come to know about so many things you didn't know before. And that's it. Keep supporting me and put your comments in the comment box below. Thank you. Like, share and subscribe the channel, and do follow my classes. Thank you. Bye everyone. Take care. This side Charu Sharma signing off.